In lesson 1.5, we're going to describe angle pair relationships. A lot of this should be review. So, two angles are complementary angles if the sum of their measures is 90 degrees. They're supplementary if the sum of their measures is 180 degrees. They are adjacent angles if they are next to each other. So, here we have complementary adjacent angles. They add up to 90 degrees and they're next to each other. Here are non-adjacent complementary, so they add up to 90 degrees, but they are not sharing a same side or a same ray. Supplementary, angles 5 and 6, when they're added together, are 180 degrees and they share a common ray. And 7 and 8, if I tell you that they add up, that they're supplementary, the measure of those angles adds up to 180, but they are not touching. I'm going to go through a little bit of review here. The sum of two numbers is 90, and one is 4 times the other. Write an equation and solve. So, if I have x plus y equals 90, and one number, x, is 4 times the other, I have a system of equations. So now I can substitute the 4y for x and write 4y plus y equals 90. So 5y equals 90. I should be able to do this in my head, but we can use a calculator. 90 divided by 5 is 18. So y is 18, one of the numbers is 18, and the other one would be 72. 90 minus 18 is 72. What kind of angle is ABD? It is a straight angle. So we talked about this earlier. I'm not going to read through all this. I think it's pretty obvious. Name that they're complementary angles, a pair of supplementary angles, or a pair of adjacent areas. So 122 plus 32 is 100 and plus 32 is 154. Those are adjacent, but they are not supplementary. 32 and 58 is 90, so CAB and RST are complementary, but they are not adjacent. And 122 plus 58 is supplementary, but not adjacent. The only adjacent ones are DAC and CAB because they share a common vertex. So in the figure below, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So 49 plus 41 is 90. So angle FGK and angle GKL are complementary. Add up to 90 degrees. 131 plus 49 is 180. So, angle HGK and angle GKL are supplementary. Your adjacent angles are HGK and angle KGF. They share a common vertex. They share a common ray, or actually segment there, JK. So our angles KGH and LKJ adjacent. Well, right away they're not because they don't share a common vertex. FGK and FGH, even though they share a common vertex, they're not adjacent because they don't share that same ray. So, measures of a complement and supplement. Given that angle 1 is a complement of angle 2, so we're getting into this word given, you don't know this yet, but it's what we're going to use in proofs. So we're told that angle 1, that means that the measure of angle 1 plus the measure of angle 2, since they're complements, is going to equal 90. So if the measure of angle 1 is 68, 68 plus the measure of angle 2 is 90. 68 plus the measure of angle 2 is 90. Subtract 68 from both sides, and the measure of angle 2 is 22. Now we're told that angle 3 and 4 are supplements. That means that the measure of angle 3 plus the measure of angle 4 equals 180. We know that because that's the definition of supplements. So we're now going to use substitution to put in 56 for the measure of angle 4. And when we subtract 56 from both sides, we get 124. In sports, when viewed from the side, the frame of a ball return net forms a supplementary angles with the ground. So this side is supplementary with the ground. They want us to find the measure of angle BCE and ECD. So 4x plus 8, using basically the angle addition postulate, is going to equal 180, because we know they're supplementary and 180 degrees is the definition of supplementary. And combine like terms, 5x plus 10 equals 180. I subtract 10 from both sides. I get 5x is 170. 170 divided by 5 is 34. So if x equals 34, x plus 2 is 36, and 34 times 4 is 136, plus 8 is 144. Angle BC, the measure of angle BCE is 144. We use equal sign because we're talking about a number. And the measure of angle ECD is 36. When you add those together, that makes 180 degrees. They're supplementary. Here is also all of the work that we've just done if you wanted to see it again. Let's go through some of these guided practices. Given that angle 1 is a complement of angle 2. So since they're a complement, the measure of angle 1 plus the measure of angle 2 equals 90. And we know that because of the definition of a complement. I'm going through a little bit more than you guys would say right now. Why are you doing all this, Mrs. Falk? Because when we get to chapter 2, we're going to do proofs. And when we do proofs, we have to write this out. And we have to write out the reason that we did this. So the reason that we wrote this is because we're told they're a complement, and this is the definition of what complement means. So the measure of angle 1 plus 8, which is the measure of angle 2, is 90. How do we know that? Because we're using substitution. We subtract 8 from both sides, and the answer is 82. Now we're going to go on to the next one. Given that angle 3 and angle 4 are supplements, so the measure of angle 3 plus the measure of angle 4 equals 180 degrees. That is a definition of a supplement. So the measure of angle 3 is 117 plus the measure of angle 4 is 180 degrees. So in this case, we've now used substitution. I'm going to take 180 and I subtract 117 from both sides, and I get that the measure of angle 4 is 63 degrees. Now the measure, LMN and PQR are complementary angles. So the measure of angle LMN plus the measure of angle PQR equals 90 degrees. That is a definition of complementary. So I'm told that 4x minus 2 plus 9x plus 1 has to equal 90 degrees. I'm using substitution there. 4x plus 9x is 13x. Negative 2 plus 1 is negative 1 equals 90. If I add 1 to both sides, I get 13x equals 91. 91 divided by 13 is 7. So if x equals 7, 4 times x is 28 minus 2 is 26. 9 times 7 is 63 plus 1 is 64. I don't know why I have a circle there. Take that out. And the answers are 26 and 64 respectively. Now we're going to talk about angle pairs. So two adjacent angles are a linear pair if their non-common sides are opposite rays. The angles in a linear pair are supplementary angles. We are going to use the linear pair postulate quite a bit in this class. Two angles are vertical angles if their sides form two opposite rays. So let's look here. We can see that angle 1 and angle 2 have an adjacent side, and their non-adjacent, non-common sides form opposite rays. With our vertical angles, if the sides form two opposite rays, so this and this on 4 versus the sides on 5 are opposite rays. We're going to find vertical angles, all the linear pairs and all of the vertical angles. So 1 and 5 are vertical angles. 1 and 4 are a linear pair. 2, 3, and 5, or 1, 2, and 3 are not a linear pair because a linear pair is 2, not 3. And if two angles form a linear pair, the measure of one is 5 times the measure of the other in this example. Find the measure. So we're going to be able to say that if they're a linear pair, 5x plus x is equal to 180. How do we know that? Because the linear pair forms a straight line. A straight line is 180 degrees. So 6x equals 180. And 180 divided by 6 is 30. You can do that in my head. Okay? And so this would be 30. This would be 150. 30 plus 150 does add to 180. Do any of the numbered angles in the diagram form a linear pair? Okay. None of these are linear pairs because in order to get a straight line, you need 3. There are vertical angles though. So angle 2 and angle 5 are vertical. Angle 1 and angle 4 are vertical. Angle 3 and angle 6 are vertical angles. And we have another problem here. The measure of an angle is twice the measure of its complement. So let's think about this, because you have quite a few problems in homework like this. So x plus y equals 90. Okay? So the measure of an angle is 2 times y. So now we can use substitution. So 2y plus y equals 90. So 3y equals 90, y equals 30, and then the other angle would be 60. And it's time for the daily homework quiz. Angle 1 and angle 2 are supplementary. So I know that you guys are probably very quickly going to say, well, Mrs. Falk, it's very easy. 180 minus 97 is 83. I want you guys to know that that means that the measure of angle 1 plus the measure of angle 2 is 180, because that's the definition of supplementary. And then I'm going to substitute in 97 for the measure of angle 1, and I can do that because I can substitute. I can then subtract 97 and get 83. Angles 3 and angle 4 are complementary. So yes, I know that you're going to say, well, Mrs. Falk, I'm just going to do 90 minus 74, and I get the answer is 16. But you also need to understand how to write that the measure of angle 3 plus the measure of angle 4 is 90, because that's the definition of complementary. Then I'm going to use substitution for the measure of angle 3 plus the measure of angle 4 is 90. And when I subtract that, then I get 16. Find E, F, H. So we know that the measure of angle E, F, H plus the measure of angle H, F, G is going to equal 180 because they're linear pairs. Then I'm going to use substitution. 3x minus 6 plus 2x plus 16 equals 180. 3x plus 2x is 5x. Negative 6 plus 16 is positive 10 equals 180. Subtract 10 from both sides. 5x equals 170. 170 divided by 5 is 34. X equals 34. We wanted to find E, F, H, so 34 times 3 is 102, minus 6 is 96. And now we want to find the measure of angle ABC. So the measure of angle ABC plus the measure of angle CBD is equal to 90. That's the definition of complementary, and we can see we make a right triangle, a right angle there. So x plus 9 plus 2x equals 90. That's substitution. X plus 2x is 3x. We're actually combining like terms here. We're subtracting 9 from both sides. That gives me 81. 81 divided by 3 is 27. If x equals 27, ABC is x, which is 27, plus 9 equals 36. Is it possible to draw a figure that contains exactly one pair of vertical angles? So no, because, okay, once you draw a pair of vertical angles, you have drawn two pairs of opposite rays. This automatically gives the other pair, another pair of vertical angles. If I draw this, once these are vertical angles, then by default, I also have this other set of vertical angles. If I draw two lines that intersect, I'm actually always going to create two pairs of vertical angles. Okay. I put this in here. This is actually, I think, from a different textbook, but I saw this and thought it would be helpful. There are some things you can conclude from a diagram and some you cannot. So in this diagram, you can conclude that all parts are coplanar. Points A, B, and C are collinear. You can conclude that B is in between A and C. You can conclude that there's a line AC, a line BD, a ray BD, and a ray BE that all intersect at point B. You can conclude that E lies in the interior of DBC. You cannot conclude that AB is congruent to BC. If it's not marked, even though they look like they're congruent, you can't conclude that. You cannot conclude that this is a angle bisector unless they tell you. You cannot assume that there are right angles here unless the book actually marks it and points it out. So I want to make sure you're familiar with what you can interpret and what you can't. And then here are the problems for your homework for lesson 1.5.